towards fog-based, human-in-the-loop cyber-physical systems for human-robot interactions in smart labs, use cases, and high-level architecture. Authors Azad Karim, Dr. Ching Tan, and Dr. Juan Carlos Alvarez. Introduction. Safe and effective interaction is the key to operating multiple robots in a human-robot blended environment, such as smart labs in educational facilities. There are two success factors here. One is the robot navigating and interacting with humans naturally, making everybody feel comfortable in the environment. And the other is robot acting as a participating member of the team, helping out with anything possible, being supportive, and taking proper actions in emergency situations. The nature of human-robot interaction calls for robots being socially acceptable in the environment. In an academic setting, performing lab work with on-premise teachers and students, or those who have joined remotely through an avatar robot, this becomes even more important, especially because of its impact on students' learning. Acceptability of robots in education depends heavily on meaningfulness and efficiency of robots' motion and movements, and communication plays a key role in this situation. To give an overview of the context, indoor lab environment in educational facilities, robot with human entities and other robots present in the environment. There may be two categories of robots: autonomous or remote-controlled avatar robots. Avatar robots can be moving in auto-controlled, semi-controlled, or following mode. The initial use case we'd like to focus on will be related to human and avatar robots in the following mode. If you recall, the following mode is the mode where the robot is following a human or another robot. The scope of interactions under study will be limited to motion and movement related interactions. There are two possible situations to explore in human-robot interactions in movement. One is a robot is following a human, and the other is robot is following another robot. Two categories of interaction in the above two situations is human-to-robot interaction and robot-to-robot interaction. We're particularly interested in robot-to-robot interaction just as much as human-to-robot interaction, because we want this category of interaction to be human understandable and transparent. We think this is key to having socially acceptable robots. Movement-related use cases. We've identified 4 core use cases. The first one would be the simple following mode, where a robot is following a person or a lead in the lab. Next would be following a human to get in touch. Robot is following because it needs to convey some sort of information, warning, or just a relay. This becomes particularly important when things are not going according to plan, such as emergencies or alarms. The third one would be to help the lead do something. This could be supporting, carrying, or some kind of personal support to the lead. The final one is robot following another robot. As we studied the use cases for movement, we also came across a number of use cases for communication purposes and messaging, and we found that these are actually more in number. The details can be found in the paper. There's roughly 8 use cases identified so far. We've also worked on a high-level architecture for human-robot interaction. We hope to detail this design and go deeper into each subsystem and implement a simulation of the initial use case. Thank you.